Right, so a little bit about me. So I'm a data scientist, AI tech lead with over 10 years of experience in sports, pharmaceutical companies, consumer apps. Been working with ranking systems for over like 10 years now. As a hobby, founder of AimRank, where we started by ranking MMA fighters all around the world. And now we're doing various data science and AI solutions. I'm also a big fan of Kamado grilling, so if anyone wants to exchange AI ideas for recipes or vice versa, we can chat afterwards. It will be fun. Okay, so problems with ratings. Most of the ratings that we see nowadays, like 5 stars, quantifiable, they all have some issues. So first of all, subjectivity bias, right? Your 4 versus my 4 is probably, it's not the same. Some people rate thing 4 if it's good but not worth buying, and some people say it if it's not worth buying, it's only 1. And there's anchoring also. So there was the study which showed that the first comment, the first positive upvote for a comment increases the average by 25%. So again, we're social creatures. We take social signals so much that, yeah, it's actually a good heuristic, but it's, again, it depends on the situation. Sparsity, right? It takes cognitive load. It's hard really to take the item or take something and really put the scale, whether it's 3, 4, 3.5 or what I'm thinking. Yeah, and basically it's an extra work that people just don't like doing. That's why Netflix found out that only when they had a 5-star rating, only the 2% really took the effort to rate things, and obviously the quality is then never questioned. Also, no uncertainty tracking. So basically from data science and from data, you probably know that the more data you have about items, so whether it's an item or the person who is voting about item, the certainty should go down. So it should be less sensitive. But most systems actually nowadays, including the ones that I'm showing down, actually are not using it. And this actually particular Amazon rating was taken from actual product. This is actually a clothing product, one of the best, most successful products ever. Maybe this is clothing. Maybe someone can guess the brand or clothing item that can be for the best sold item on Amazon. Any guesses? You'll get to choose one of the sneakers or Bueno. Sorry? Not a baseball cap. Anyone else? Okay. I take one more guess. Underwear. Actually, it's Crocs. Yeah, this is one of the examples really that, as Python itself, that simplicity just sometimes kills the markets and just takes over. And basically, yeah, this is the best thing ever. Okay, so from Crocs to math, actually, so that's a big jump. But yeah, this is the only math slide that I have, but I really had to put it here because it's really at the cornerstone how the current large language models and the LLMs being aligned to the human preferences. So this was invented in 1952 by two basically statisticians who were evaluating how different diets for pork affects the taste of the pork. So there was like different diets. Judges, you get two steaks, you choose one, and basically based on that, they really took it and basically created a maximum likelihood estimation from from comparisons and to ratings. And basically the derivation of it actually is now used basically in all the alignment reinforcement learning, as well as the direct preference optimization. And this is basically quite important. I mean, PageRank, this is PageRank is not exactly pairwise ranking algorithm, but it's closely related. This is the famous Google one, and also basically the basically the idea is that links to other websites uh, count towards the importance of that website, and basically the quality of that. The initial link also is valued weighted based on how many links are coming. So basically it's a vote algorithm. And now basically some altman and everyone is talking about $1 billion solo companies. What about like $1 trillion Python 10-liner? So this is actually if you extrapolate that deeply, the simple ideas apply to scale really can be valued a lot. But going back to the rankings and the Bradley Ella. So this is the proper binary A versus B ranking system. Very famous, invented in 1960s by the wonderful grandmaster Arpatello, and basically there are like 2,000 players around the world. He just wanted to rate who is better, and he was doing at the time all the calculations by hand. So people were sending results, and he basically applied it and was able to rate all the available professional players, and basically it was respected and still used, and used in other games and other applications as well. So again, this is one more extremely simple idea and very successful idea, which basically the core comes in the few lines of Python code, and again, $2 billion per line probably. Yeah, so sometimes, when I'm thinking about the ranking systems and how the simple ideas can, if applied well, just scale so much that just think about Ella. It doesn't matter, which country you're from, which continent, which age, which language you speak. You meet someone in another place, you sit at a table, you don't speak the same language, but you know each other. Ella, you immediately can know each other, skill, experience, you know what to expect. There's so much non-quantifiable information that really is in that single number. That's a beautiful idea. That the same with PageRank. I'm not gonna tell how much it basically helped us to basically just navigate all the mess in the internet. And Bradley as well. Bradley is the way we now are actually aligning what us people prefer versus what AI models and large language models are doing. So at the core, A versus B pairwise ranking is everywhere. Dark horse, Glico. So so this is my particular favorite. So I've used it extensively. So L has some issues. So basically, Glico extends on Ella by quantifying uncertainty. So if you imagine that a player's skill is like the distribution, so Ella keeps it constant and just switching, and basically the Glico adds ability to also automatically basically narrow down, change the shape, and basically that allows you, if you do the proper data science techniques, really just to apply to any domain. And that's why Glico is a little bit under shadow, because people it's open source, so people use it, adapt it to their field, and basically change the name, and basically it's a different ranking system. So basically what my experience was with it, so I was writing, it's a little bit about a personal story, didn't say it in any public appearances, only friends. So basically it allowed me to pay my rent during my master's degree. So basically I was doing my master's on ranking systems, and I'm a big fan of mixed martial arts. So I kind of took all the fighters that I was able to find, all the fights, and basically used a very standard data science pipeline where you have the history, you basically treat it as a machine time series machine learning problem. Everyone starts from the same rating. You kind of run the simulation, stop at any point, kind of try to do the predictions for the next period. You get the probabilities, compare it against the true values. You train more, and when you do this several period metrics, you get the log loss, and you do the Bayesian optimization. Means that you have the glyco parameters, and you can do these circles over the whole history of fights, I don't know, 20, 30 or 40 times, and you get a glyco system basically optimized to your field, to MMA, but it can be different sport. So I was able to have a good accuracy, was definitely better than any of the systems other organizations or other websites were using, but obviously it wasn't enough really to be able to kind of bet and be able to have a margin against the bookmakers. So it had to be one of the features of the XGBoost model, but it was still the most significant feature because it was so complete. On other data points, you don't have such a complete data, and basically, yeah, it allowed to really help me to finish my degree. Okay, so what are potential use cases that I can think of? So, yeah, ranking systems can be applied so many places. So feature prioritization, you have like 40 features. You just do A to B form, and you apply you just send the forms to people. They do the A to B ranking, and it gives you a preference stat. You can do the board games, for example. If you do like the computer games nowadays have a very sophisticated and very good rating and matchmaking systems. But for example, if you have some family or some friend group, and you kind of want to track each other's skill over the years, it's for a developer with the cloud code, it's extremely simple to have this. Content moderation is another one which actually we are using now. We're trying to use it in one of our applications that we're building, because in the video translation. So because with the current AI models, the outputs becoming so complex and diverse that it's so difficult again to put one metric and optimize on it. And at the end of the day, you have to go back to what human thinks, and really just tell which is the higher quality. And when you do the glycal ratings, and it becomes your objective metric. And LLM evaluation. So basically, we all know all the companies release papers, benchmark here, benchmark there. They kind of want to all be on the particular benchmark the best, so they kind of choose the ones that they actually did perform well. So LLM evaluation, LLM chatbot arena kind of allowed to democratize the ratings and basically have a global and open source way to see which model performs the best. Okay, so very quickly about AIMRank, what actually we are doing in the backend. So basically, we had the system designed for MMA, but over the last few months, we just took down all the backend, and we just kind of repurposing it to be a completely abstract, very applicable to any domain with the smart matchmaking and all the other fancy features, which probably wouldn't be possible for a group of a couple of people or a couple of friends as a side project to be able to do. But nowadays, actually, the work is going quite well. So we hope to release it in the next few months or so. But in the meantime, I invite you to scan this QR code and actually vote on some of the features that have been added to Python over the last 5 years. So this is again probably for the hardcore Python fans. So these are probably one of the most, at the time when they were added, they were quite controversial, but at least some of them I know. But nowadays, really nobody can imagine Python without them. And I think it should work on the conference web, but it should work on your mobile. Oh no. Okay. Anyone can log into this? No? Okay, that's unfortunate. Yeah. Okay, so no one can log in to this QR code. So yes, no, we won't know what is the according to this from the best feature. I mean, in my opinion, this is type hints. At least the interesting fact that Instagram actually they annotated their whole 2 million kind code base once the type hints were released, and basically it immediately reduced the production bugs by 30%. So it's a wonderful feature. Right. So if I had to leave you with one insight, yeah, we all live in more and more options, and basically where models are becoming more and more complex and capable, and it's becoming so human preference in a context is becoming more valuable, just because the models themselves, their outputs, you cannot put a single number around. So that's why rating systems and ability to extract information from the human preferences will remain extremely valuable. So as I learned in my economics degree that all models are wrong, some are useful, and useful are usually simpler. Let's connect, and thank you very much.